Welcome to lesson 3.5, solving systems of equations. So in this lesson, you are going to be able to describe what a nonlinear system of equation is. You're going to be able to solve systems using graphing, substitution, or elimination, and you're going to solve quadratic equations by graphing each side of the equation. So let's get started. In Algebra 1, you learned how to graph linear functions. Remember, a linear function is a straight line. So we're going to start off, do a little review of graphing and using substitution to solve a linear system. We actually used elimination in Chapter 2, Lesson 4 in those long problems, if you recall that. So let's get started. First off, there's a typo on the program where it made this a 4. So if you will change that to a 1, if not, it will give us the wrong answer. Okay, so first thing we're going to do is solve by graphing. So remember that when we graph, the b value is your y-intercept, and this is your slope. So same thing with this one, y-intercept, slope. So we're going to start off with graphing our y-intercept. So we have positive 4. So we got 1, 2, 3, 4. Then we're going to use our slope to find the next point. It is negative, so we're going down. So 1, 2 over 1, 1, 2 over 1, and so forth. So this is the equation y equals negative 2x plus 4. Now we're going to graph the second one and see where they intersect. So we start with our y-intercept of negative 1. Again, if you didn't change that, you need to. And then our slope is 3. So we're going up 1, 2, 3 over 1. 1, 2, 3 over 1. And if you like to put the points of the past, you just go, or this way, you just go backwards. So over 1, down 1, 2, 3, and it will help you to make your graph a little more straighter. So this is y equals 3x minus 1. So we have our two equations graphed. So now our next step is to look for a point of intersection. Well, as I was graphing it, I saw a point of intersection. They intersect right here. That's where the two graphs meet. So what does this mean? That means this is our solution. This is the only value for x and y that work for both equations. All right, so now we're just going to check and make sure our answer is true. So this is the point 1, 2. So 1, 2. So that is our point of intersection. So you can check your work to make sure that your solution works. So we're saying that our solution is 1, 2. So we're going to start with the first equation. Y equals negative 2x plus 4, and I'm going to substitute in the x and the y values. So remember, this is your x, this is your y, so 2, and for my x I'm going to substitute in 1. Alright, so we're just trying to figure out, do those two sides equal? If they do, then we know our answer is correct. So we have 2 equals negative 2 times 1 is negative 2, plus 4 is positive 2, so that one works. So now let's try the next one. Y equals 3x minus 1. So we're going to substitute in 2 for our y value, 1 for our x value, and see if they equal. So 3 times 1 gives me 3. 3 minus 1 gives me 2. So 2 equals 2. So that one is good as well. So this is just checking to make sure my answer is what it is. So our solution is definitely 1, 2. Guys, put your parentheses, because it's not an ordered pair if there's no parentheses. Some of y'all are lazy. That's too lazy. Alright, so now that's what you can do by graphing. Graphing is most people's least favorite, including myself. I much rather prefer substitution or elimination. So we're going to look at this same function, but we're going to do it with substitution. Now keep in mind the equation is 3x minus 1. They because of the typo, so we're going to keep with that. Alright, so this is another way that we could solve the same exact thing. So it says equation 1 is already solved for y. So we have equation 1. Here, I'm going to write them here. I'll come right back. Alright, so equation 1 is already solved for y because it says y equals. So we're going to substitute this 2x, this negative 2x plus 4, into y to solve for x, because we can't solve for two variables at the same time. So we're going to take this part, we're going to substitute it in to there for the second one, and then we're going to solve for x. So we're going to say, I guess I kind of did it backward. No, I didn't. Okay, so we're going to say negative 2x plus 4 equals 3x minus 1. And then we're just going to solve for x. All right, you guys should be able to do this part, so if you want to pause and work it out, and then come back when you're done. All right, so after solving this function for x, we get x is 1, which is what we said our solution would be, because remember, this is your x value, this is your y value. So now we're going to substitute with the value we found for x, so 1, into equation 1 and solve for y. So I'm going to take my equation 1, and instead of x, I'm going to substitute in a 1 and solve. So negative 2 times 1 gives me negative 2. Negative 2 plus 4 gives me 2. Is x comma y, so 1 comma 2. So those solutions are the same. That was the idea. Okay, so I'm going to put some equations up here. Because this is Algebra 1, you are welcome to practice it if you need a little extra practice. If you feel good about these and you want to move on to the next step, you can go for it. I am going to I'm not going to graph because I don't have a graph here, but I'm going to do substitution, substitution, and if you haven't remembered elimination, I'm going to do elimination with number 3 just to remind you from lesson 2.4. So I'm going to go ahead and work those out. If you want to pause your screen and give any of these a try to challenge yourself, go for it. Come back to see if you're correct. Okay, so I have the first one done for you. So I did this one by substitution and found that the solution is 1 comma negative 2. So with any of these guys, I'm trying to show my work so you can see where maybe you went wrong if you didn't get that answer, and you're always welcome to ask questions in class. All right, so go ahead and pause and try number 2. Just to make sure, in this case, both of the equations are set equal to y, so I'm going to replace this y with what y equals here. Okay, and here's your solution for the second one using substitution. Now this third one I am going to do using elimination. So I can see that my y's are almost able to cancel out. So I'm going to multiply this equation here by 3 so I can have negative 3y here. Now if you wanted to solve for y and then substitute it in like 1 and 2, you could do that as well. So come back and check your work. Okay, and so here's the last one. So again, I just multiplied everything by 3 and I got this new equation. First one stayed the same. This way I was able to eliminate my y values and solve quickly for x, and then substitute it in, got my y. Here's our solution. All right, we are going to move on to example 2. So now we're on to nonlinear. So what's a nonlinear? Not a straight line. All right, so it's not a line. Maybe we should make that a straight line. Let's do that. Parabola. So we can also use graphing, substitution, and elimination to solve systems of nonlinear equations. So here are some examples of nonlinear with a linear and how you would find your solution. So if they don't intersect, there's no solution. They intersect one time, that's your only solution. They intersect twice, you have two. Then if you have two nonlinear functions, so two parabolas, this is how you would determine how many solutions they have. They don't intersect, you got none. They intersect once, you got one. They intersect twice, you have two. Okay, so let's graph. Now, we have a parabola and we have a linear function. So linear function is a little easier to graph. This one, though, we have learned how to graph it. We know right away that this -1 is our y-intercept. So we can go ahead and graph that. -1. So that's our y-intercept. And now we can find our vertex by doing x equals -b times 2a. So we're going to look for our vertex. So we have x equals -b over 2a. I think I said times. So what is our b value? -2. So we have -2. And then our a value is 1. So over 2 times 1. So -2 gives us +2. 2 times 1 gives us 2. So that equals 1. So right now, our vertex, the x value, is 1. How do we find the y? We take our x value, substitute it into our equation. So we're going to find y by saying 1 squared minus 2 times 1 minus 1. So 1 squared is 1, 2 times 1 is 2. Then if I take 1 minus 2 is -1, minus another 1 is -1, or -2. You could also think about it as this one and that one cancels out, so you're left with -2. So that is the y value of our vertex. So now we can graph that. So 1, -2. So because our graph is positive, we know that it opens up. We know this is our y-intercept, this is our vertex, so this is going to be our lowest point. Now, because we know that we have that little axis of symmetry right there, we're able to graph a point the same distance away on the other side. Now, if you wanted to find some more points to make your graph more accurate, you could. Because these are so close together, I may go ahead and try 3 and 4 just to kind of give me, because I am looking for that intersection point. So just to kind of give me a few more points. Okay, so I am going to find another point. I'm going to do it when x is equal to 3, because we have the 3 right here. 1, 2, 3. So see, when x is 3, what is y? So how do we find that out? We do this last step here. We're going to plug in 3 for x and solve for y. So we have y equals 3 squared minus 2 times 3 minus 1. So 3 squared gives us 9. 2 times 3 gives us 6, and we have our minus 1. So 9 minus 6 gives us 3. 3 minus 1 gives us 2. So we have another point, 3, 2. So we go to 3, up to 2. Now remember, again, because of that axis of symmetry, right, my axis of symmetry would go right here. This one's 2 points away, so I can plot another one right there. So now I feel like I have a better graph. If you wanted to go further, you can. I don't know that the next ones would fit on the graph per se, like with 4, but I wouldn't go past 4 or -2. All right, so we have our first graph. This is y equals x squared minus 2x minus 1. Now we're going to graph our linear function. I want you to pause the video and go ahead and try it, because that one's like the previous ones. I am going to graph this next one in a different color just so you can see. Now when I have my lines, they look really close to this graph, but they really only touch right here at this point. So this is y equals -2x minus 1. So they only touch right here. So this is our only solution. So we're going to say that the solution is, what is this point? 0, -1. So now you can check your work by plugging in the x and the y value into the equations, see if your solution is true. So that's the great thing about math. A lot of times you can check your work to see if your answer is right. So pause the video, check it, and we'll come back together. Alright, so now that we have checked it, we've used our X, our Y to check it, we see that it is a solution. So our solution is 0, -1. Alright guys, I'm going to stop the video right here, and then we're going to pick it up with example 3 and 4 and then try some self-assessment questions. So I'll see you in the next video.